There we go. Okay, everybody. Nice to see you all again. Some familiar faces. So today we're going to talk about applying microservices patterns and best practices to identity management and how that applies. This is just kind of a diversion. So this is me looking at the tweets about the ID Pro meetup in the Augustiner last night and thinking, oh man, I really missed out. So how many of you saw this headline recently? Very recent headline, very eye-catching, especially I'm previously an evolutionary biologist, so I thought, wow, extinct species of bird comes back from the dead. Anybody see that one? So immediately I thought, scientific wheels go in motion, and I thought there had to be only one logical explanation for it. I think we all know what that is. But obviously not that. So what happened was that there was a species of bird colonizing an island from Madagascar, and eventually it would evolve flightlessness because in that ecosystem, in that landscape, one of the optimal selection models was for a bird that could succeed better if it were flightless. Didn't need to fly, didn't have predators. So what happened was when the sea levels would rise, the birds would go extinct, the sea levels would fall. Eventually, the same birds from Madagascar would colonize the island as birds that flew. But the optimal niche or the optimal model for them to pursue in that environment was flightlessness. So it's not the same bird that came back from extinction, but the same generation. So what does this point to? Something in biology we call the vacant niche hypothesis, that within a landscape, within an ecosystem, that it's not a random roll of the dice. That there are, if you imagine these niches where there are optimal sets of traits for performance to succeed in an environment, those niches exist. And that eventually, whatever type of animal comes in, whether it's a lizard, a frog, a mammal, that they will all evolve within that landscape into those optimal niches. So if you look at North America and the wolf, a top predator in its ecosystem. If you look at Australia, the thylacine, the Tasmanian wolf or tiger, it evolved from a completely different stock, 100 million years separated by genetic distance, into something that was almost the same, because in an ecosystem, that was one of the optimal niches. Same thing goes if you look at a mole, very, very different than a top predator like a wolf, but there is a niche clearly in an environment where an organism can succeed if it models itself and fits into those adaptive traits in that environment. So what does this have to do with security, with the digital landscape? Well, if you imagine the digital environment that we're walking into right now, that we're entering, where companies are scrambling to transform themselves from brick and mortar into this new digital landscape. Imagine it as a new island chain forming, a whole new land formation. Within that environment, there will be optimal niches for a business to occupy. So the question is, how can your organization or your business find those niches faster than your competitors? Because again, if a lizard could take the same niche as a mammal, so you need to be into that niche before your competition and find out how to conquer this new digital landscape. So digital transformation is a huge topic right now. If you look at the stats, every organization we talk to, even if they're in a commercial industry, if they're in a nonprofit industry or governmental organization, they're all going through digital transformation. How can they get closer to their customers? How can they be more consumer focused? How can they use a digital platform to engage with their end users? MIT study found that organizations that underwent digital transformation, on average, were 28% more profitable. They had longer customer lifetime retention values and more sales per customer. So it's exceedingly important right now to get into those optimal digital spaces before your competition. If you look at the McKinsey model, McKinsey doesn't call it digital transformation. They call it basically a perpetual evolution, which is kind of like the previous gentleman said. It's really something that even if you're already transformed as a digital company, you have to continually reinvent yourself. You have to continually reinvest and get creative to get closer to your customers. So if you look at, McKinsey looked at the IT landscape and what are the implications on your infrastructure, the way your organization manages software services from an IT perspective to handle this perpetual innovation or digital transformation. And some of the key things is that you need to emphasis on decoupling applications. So instead of having applications that this one has to talk to this one and it's very tightly bound, that if this changes, this application instantly breaks, that you need to decouple and have these looser relationships, more standard API interactions at a distance, so that as long as I present you this data in the format that you expect, my application can change on its own. It's not tightly bound to your application. Also, lightweight connections. So an emphasis not on the traditional SOA model with enterprise service bus and heavy integration, but more just on loose, RESTful API interactions. Also, a focus on DevOps, that you need all of the team to focus on not only developing the software and then throwing it over the wall for testing, and then they throw it over the wall for deployment and management, but a DevOps model where you're continuously developing, operating, deploying to put software out there faster. And fewer handoffs mean better quality. And then looking at your IT infrastructure, and this is definitely the trend with the cloud, is that treat it as a complete commodity. Do not get heavily invested that you care so much about the IT infrastructure, and that they even say to separate out that team so that it doesn't basically contaminate your software group, which is focused on the consumer journey, the consumer life cycle, and rapidly deploying software on commodity infrastructure. So some of the buzzwords out there as you're moving towards a more microservice model, it's all about containerization, so making your applications that can be deployed across Docker, Kubernetes infrastructures, which allow you to scale them very rapidly and elastically with less hardware. Orchestration, which manages the software, scaling it out as needed. And then, of course, microservices, which we're here to talk about. So microservices, you might have heard the term probably many times since you've been here. It's definitely a buzzword this year. You see, if you look at the news, you'll see it everywhere. Now, last year when I was talking about microservices, we had a panel on serverless computing, microservices, and I said basically, it's here, it's now, it's happening, we have to react. A lot of the stares I got were kind of like I said that next year we'd be eating Tide Pods and that would be a normal thing. But if you look at the statistics, adoption of container-based microservices has gone through the roof. In a very short time, it's become the norm, and all the vendors are deploying software quicker, faster, across any infrastructure, and across any cloud. Microservices is one of those things that basically, once you get it, once your brain clicks and you see the difference, you can't unsee it anymore. Once you see it, you can't unsee it. You realize that there's no going back. Now, my microservices Gestalt moment was basically when I fired up on my Windows 10 laptop. I ran a few commands, and all of a sudden I'm running SQL Server 2017 on Linux on my Windows machine. It's like at that moment it clicks that now the infrastructure doesn't matter, it's portable, it could be deployed anywhere very quickly, even by somebody like me. Of course, instantly, well, not instantly, probably a little while later, the alarm bells kind of went off and said, okay, if I'm a user and I'm a local admin and I'm on the network and I have IP access to other machines, I can basically launch almost anything on my machine. I could be launching my SQL server, a web server. I could be launching something from a repo out there that is running malware scans on the network. So definitely a very dangerous thing, a very different mindset, but it's a change that's here and it's not going back. So what is a microservice? How many people are using microservices in their enterprise today? So at least half, so looks like it's matching the statistics. That's good. So basically, in the old world, the monolithic world, which is what the bulk of our applications are. I mean, we all want to live in a microservice world, but we're not there yet. You still have legacy. You still have your line of business applications. In a monolithic world, the application, you had the traditional application stack. You had the user interface that was the same application or same code base that talked to your business logic layer, that talked to your data access layer, and typically you had one big monster database. And when you needed to deploy a new version, it all had to go together. You couldn't modify them independently. So when you deployed it, it was slower. it was riskier, you're more likely to break something, and you have to do a lot more testing. So it's like a big beast that's very difficult to move forward because it's a risky step every time you do. In a microservices world, if you imagine that each application function is independent. So it's broken down to where a microservice does one thing well, and then it can be communicated with from other user interfaces or other microservices via just standard lightweight REST APIs. And it can have its own release cycle, it can have its own team, it's technology agnostic. This team can use a different technology than this team, it doesn't matter, because the generic interfaces, how they talk to each other, kind of normalize that. And also, typically it'll have its own database or its own data store. That way, it's as few dependencies on other systems as possible. So you can move a lot quicker. So some of the characteristics, I borrowed the little picture on the right from Microsoft, nice reference application, but it shows a typical microservice infrastructure. So your identity component, your authentication might be a microservice. Your authorization engine might be a microservice. And then if you're looking at a shopping cart app, the search would be a microservice. The basket would be a microservice. The marketing would be a microservice. That way, let's say that the search is something that leads to more consumer transactions. Finding the product allows them to buy the product. So you want a different team that has the flexibility to use whichever technology they want to iterate very, very quickly, because that's going to be a key differentiator, part of your value proposition. And you don't want that search team to always be bogged down to where they can't deploy until the basket team deploys, and they have to wait on the order team, and then everybody's in this big database where you're checking in changes, and then you have to retest everything, which takes 2 to 3 months. You want that search team to be able to deploy every 10 minutes if they had to. I mean, that's really the model. So the characteristics of a microservice, decentralized. Definitely everything is loosely coupled, decentralized, nothing really centralized or put together that's not necessary. Independent. Each can be changed independently. Do one thing well. Polyglot's basically the idea that you can use any type of technology you want. Polyglot persistence means that this microservice, if it's better to use a NoSQL database, it can use it. This one can use a SQL database. So you don't really have to care about that. Black box means that nobody needs to see really what's in the microservice. It's just going to expose some functionality. And then the whole DevOps mindset that you build it, you run it. Now, an important thing here on the microservices is not just the technology, it's not just the tooling, it's really a cultural change. So, and I would say that even without the microservices, the cultural change is needed in order to achieve digital transformation. Conway's Law says that the software an organization builds is directly a mirror of their organizational structure and communication style. So if you have a big top-down organization, you're going to build big top-down software. So really you have to restructure into small teams in order to build software that is faster, lighter, quicker. Your team and your organization and communication has to match that. Bezos at Amazon has a rule called the 2-pizza rule, that no software team should be larger than the number of people that could be fed by 2 pizzas. If you need more than 2 pizzas and your team's too big, it's going to be slow, and you're going to be tainting the design. So are microservices required? It's a quick story. Spent a summer in Zurich. Everybody goes swimming in the evening, if you could, in the Limmat. And it has a pretty fast current. So if you're going downstream, you can just jump in, float downstream, you have a great time. Some people were brave souls. They could swim upstream. And they were like endurance athletes. I would watch them go by. And some people can do it. So you can do it, but it's definitely the hard way to go. And it's for only a few. So common microservices patterns that we can look at, one that we all know very well, federated identity. The idea that the identity is external, that your microservice consumes the identity, that you're not replicating identity management in each of your microservices. Gateway routing, you really can't do microservices without gateway routing, because imagine that you have hundreds of these microservices. You're not going to have your web applications or your mobile applications making direct connections to hundreds of applications. So naturally, you're going to be routing through a central point. And that allows you to implement gatekeepers. Gatekeepers allow you to implement some security, some filtering, and some other logic. Anti-corruption layer we're going to talk about. and then Sidecar. So Sidecar is probably the most important concept, and I'll come back to that one, in microservices. And it's the idea that if a microservice is going to be slim and do one thing well, then you don't want to build into your application, your microservice, logging, anything that you don't need. So in the idea of a sidecar is that in your microservice environment, they're almost as if each microservice is running on the same physical system like their processes in a Windows server. So you can say my microservice is just going to log out to the file system, and another sidecar will swoop it up and send it off to my syslog server. So the idea that you can decouple functionality and have specific sidecars that run in any technology you want that add on filtering or add on ingress control. So the idea that your microservices, there's some sidecar controlling access and applying security policies, authentication, authorization. It lends itself immediately to a zero trust, because in a zero trust model, all access is proxied. There's no direct access. And a microservice deployment, basically you have your ingress controller, which is controlling everything that comes in. They can talk to each other internally, and nothing else gets in. So it's naturally a zero trust model as a side benefit. I'll speed up a little bit. So identity and access management really represents, in the microservices model, one of the concepts, an anti-corruption layer. So the anti-corruption layer is designed that you have other systems, legacy applications, or external systems that have their own models, and you don't want to corrupt your internal model by modifying it to fit those systems. So it's a layer in between that translates. So how does that apply to identity and access management? Basically that you can have your own business processes, your own logic, your own joiner, mover, leaver, your own permissions or authorization model. And the identity management system should be that anti-corruption layer that it translates your model into the external systems model that they can consume or they know. That way you can manage your security in one spot, you can manage your permissions in one spot, and you're not building in, let's say, the Salesforce permissions model into your identity management system and this other model, or changing how you would do your business processes. So I'm going to skip some of these just because we are out of time. Just one important thing. In the authorization, cloud-native authorization model, you have all these microservices. You can centralize authorization, like at the ID there, where at the ingress control, you're performing your authorization decisions. But in a microservices model, it's typically more distributed to where each one can independently talk to its own sidecar to perform authorization decisions for scalability and for decoupling. So recommendations. It is a do or die proposition. I'd say focus more on the cultural transformation. One thing that's painful is that, I've got a little typo there, but you may not be able to use all of your existing team. You might need to get some new blood and then sprinkle your existing team into these new teams, kind of diluting the previous model with people who are more used to working in this model. That way, if you're going to transform the organization, you really need to have some fresh blood, typically. And of course, think about the inside-out model that identity and access management, you can't count that you're going to be able to push and talk to every system. They're in these little bubbles with ingress control. So you really need to think about how can I run things inside that will reach out, pull the information necessary or submit the information necessary, and then perform decentralized local enforcement, local actions. And that's it.